Okay, so we are on the angle bisectors today. Our angle bisectors. So like the word says, an angle bisector cuts an angle in half, right? So now the angle bisector theorem states you have an angle bisector, and if there is a point on that bisector, it's the same distance away from both the sides of that angle. So like in our picture here, that would be segment FE and FD. Those guys would be the same length because F is the same distance away from both sides of that angle. Just a good refresher, what does that upside down T mean again? Perpendicular. Yep, good. Okay, the converse of that is if we know a point is the same distance away from both sides of your angle, then it's on the the angle bisector. Again, why do we care? We just care because this helps us find, oh my goodness, because I cannot talk it. It just helps making measurements easier to find. All right, so if we throw some numbers to these examples here, what would xy be? 7, right? Because this is an angle bisector, so we know that x is the same distance away from both sides of that angle. Measured angle JKL. 37, yeah. We're told that these two segments are the same, so it's on the angle bisector. Perfect. All right, just a little bit of algebra on this one. We're looking for SP. What's an equation we can write, folks?
3x plus 5 equals 6x minus 7.
You got it, buddy. There you go. Is for her answer? Yeah, plug it in. Plug it in. (24 minus 7 should be 17. You guys get a head start on the next one. Label your picture. Bless you. What did you guys get for BC? Good work, folks. Okay, so let's talk about what happens when all of those angle bisectors intersect in a triangle. You remember, right? They create that point called the incenter. The incenter. Do you remember why that one's called the incenter? When you guys drew your circle on this example in that task thing, where was your circle on this one? It was inside your triangle, right? So if I were you, I'd sketch in a little circle here, right? P's the middle, and it kind of looked like that. I mean, obviously my circle's terrible because I can't draw, but you could circle or sketching that circle. That's why it's called the incenter, because it's inside that triangle. So now if we look, PF, PE, and PD are all what of that circle? What do you guys call those segments? They are equal, but why are they equal? Close. What's it called from the center to the outside of the circle? What's that segment called? Nope. Think of like 7th grade. That's where we would have learned this. From the center of the circle. So close. That's all the way across.
Radius.
Radius. Yes. So because of that, all of those little segments are equal. Because your incenter is the same distance away from all the sides of your triangle. They're all little radii. All right, now they want us to list the 3 angle bisectors. So what are cutting our angles in half, you guys? What segments? Yep. And I wouldn't highlight those ones because they're not the same length. These guys in here aren't all the same length, so I wouldn't highlight them. But you guys can tell that AP is cutting angle A in half, right? BP and CP. Those are all your angle bisectors. Okay, what's our incenter? B. Now we have a bunch of congruencies that exist. Now this is where I take out like your little different colors, okay? The only problem is there's nothing marked on our picture right now. So is there any that you guys know? Anything that's equal? What if I said DB? What would DB be equal to? Yes, BE. So that's what I would highlight. Those two are the same. We'll just kind of work our way around it. Just sure if that's okay. EC would match. So close. F, C. There we go. And then our last one, FA is congruent to AD. Okay, last one I lost. And that last line reserved for our 3 radiuses of that circle, which would be what, folks? Yep, all those red ones in there. All right, let's try this example. Hopefully that makes it a little bit more concrete and easy to understand. Okay, NP, what's NP going to be? 8. Perfect. There's one more thing that's 8 in your triangle. What would it be? PO, yep. I'd probably label that too, just it's good practice. NK. Okay. Right, you guys agree? These two would be the same? Yep, 17. Okay. Let's see here. PK. What do you guys think for PK? Yeah, right. Don't forget that's a right angle there. So we're gonna have to do Pythagorean theorem. I sketch out that triangle below just so you kind of remember what you're looking at here. Okay, what side is our hypotenuse? Good job. Yep. Yeah, and don't forget exponents come before adding and subtracting in gender, so we got to square those numbers first before we add them. Square those numbers first before you add them together. (17 times 17, 289), right? But 64 plus 289. And we gotta take a square root. Let me know what you give. Gonna be a decimal. 18.8. We agree? 18.8? You guys try to find LO on your own. You have to do Pythagorean theorem again. See if you can find it on your own. Trace with a circle if you or triangle if you have to. Thirteen's your hypotenuse on this one, so that should be the guy that's by itself. (10.2) if you round. Okay, good job, folks. All right.